Hello students. This session we will see about heap sort algorithm. So we know many sorting algorithms are there and we discussed many sorting algorithms like bubble sort, selection sort, quick sort, merge sort, etc. In this session we will see about heap sort. This is very interesting algorithm where we are going to construct tree structure, tree pattern with the given elements. With that tree pattern, we can make sorting of the given elements either in ascending order or in descending order. So both the way is possible. Okay. So with the given elements, we have to construct a heap. First step is we have to construct a heap. We will see how to construct a heap. Next step is whether it is ascending order or descending order. Based on that, following some properties, we have to construct or we have to decide whether I should construct min heap or max heap. What is min heap in that tree? If you consider any parent node, that parent node should be the minimum value than its children. That is min heap tree. Whatever the node you take, that node value should be the minimum comparing with its children. We'll come to max heap tree. What is max heap tree? In the constructor tree, if you consider any parent node, that parent node value should be greater than its child node. That is max heap tree. So once we constructed heap, then from that heap, if we constructed equivalent min heap or max heap, what is the next step? So if it is min heap, after constructing min heap, we have to remove the root element or we have to replace the root element with the last element. In that way, we are removing one by one, because in main heap, what will be the root element? The very smallest element, right? Because that is the property. So obviously the root of the tree should be the smallest value in min heap tree. So likewise, one by one we are removing. And what will happen in max heap tree? Just reverse. In max heap tree, the root of the tree should be the largest element. So we can remove that largest element one by one and we can make a proper order. So what is the first step? We have to first build a heap with the given elements. And if we need ascending order, we have to construct min heap. If we need descending order, we have to construct max heap. We will see how to construct min heap, max heap. Just you should note the points as now. So as I told, whether once the heap is created, we have to delete the root node from the heap. And we have to bring the last node to the root position. And again, we have to check for the steps till all the nodes are sorted. Right? These 4 points are very important points. Next, we will see with 2 examples. Example 1 we'll consider 6 elements. Okay, before that some points we have to keep in our mind. So as I told, very first step is we have to build heap. Then later, based on ascending or descending order, we have to transform this into min heap or max heap. And what's the next step? Delete the root node. Then we have to bring the last node to its root position. Then anyway, again, we have to repeat the steps from 2 till all the elements got sorted. These 5 points are very important points. These points should be recursively done. So just we'll consider few elements. We'll consider 6 elements here. So 6 elements, when we are constructing heap, we will have 6 nodes, right? In a tree structure, we will have 6 nodes. Here, always arrays index start with 0, right? But here, while reading the element, we are just reading the element from 1. We are just saving elements from index 1. So it will be easy for few calculation or understanding. That is why purposefully we are reading from 1. It's a just equivalent array representation of the given elements. See, this is the input element and this is the equivalent array index. We'll try to build heap. So in what, by following which property I can build heap, right? So it should be a complete binary tree. The tree which we are going to build, it should be a complete binary tree. What is complete binary tree? That is, each and every level should be filled. Each and every level should be filled. And then whenever new element is coming, it should be filled with left to right. Once the level is filled, then only we can go for the next level. Once the level is filled with all the elements, then only we can go with the next level. And while filling the elements, it should be filled from left to right. So these are the common properties. It should be a tree. And of course, what is tree? Each node can have at most 2 children. It can have 0 children. It can have 1, or maximum it can have 2 children. And it should be a complete binary tree. All the levels should be filled. Once the level is filled, then only we can go with the next level, and elements should be filled from left to right. So I'm starting with 40. See, the first element can be considered as a root element. So what is the next point? Next element 60. So we know that it should be filled from left and then right. So I'm just filling in left. So what is the next element? 10. 10 should be filled to the right of 40. So that next level is filled. Now I can come to the second level. There again it should be filled with left to right. Correct. See, I am receiving 20. 20 I should fill from again left to right. Since this level is filled, then only I am coming to the next level. And again I am starting with left. Here both children is filled. I am coming, putting here, and no more elements. This is just equivalent heap, right? What properties we have to follow? Complete binary tree property to create a heap. That's it. Now we will try to create min heap. Okay, so what is the property of min heap? What is the property of min heap? As I told, the parent node should always be smaller than or equal to. That is also fine. Smaller than or equal to its child nodes. Right? That is the property. So we have to keep that property in our mind while constructing main heap. And when to start, where to start, in which node I have to start for checking whether it is proper min heap or not. So there is a rule, right? You have to start with n by 2 index, right? So this is first index 1, 2, 3, 4, 5, 6. Again, first index, second index, third index, fourth index, fifth, sixth. So where I have to start? In the n by 2. So totally n is what? 6. Okay, 6 by 2. So I should start checking in the third index. First index, second index, third index. Okay, we will see how it is happening. So what is the rule? If there are n nodes, we have to start comparison from n by 2 index, right? Why we are using here n by 2? Because we are floor of n by 2. We are just have interest on only integer part, right? So it will give the nearest integer value. It will lower down to the nearest integer value. That is why we are using floor method. So here total number of nodes is 6. So if we do floor of n by 2, obviously it is 3. So where I should start? First index, second index, third index, nothing but 10, right? So from this node, I can start the comparison. Any child node smaller than 10? No, right? Now, the 1, 2, 3, third index I have checked. Any child of the 10 smaller? No. This is perfectly fine. So this is done. We have to move to the next smallest index. This is third index. So I can move to the next smaller index is 2. So second index I'm checking whether any of its children is smaller. Can you guess any of its children is smaller? Both are smaller. Among these two, which is smaller? 20. So I can replace 20 and 60. If it violates the min heap property, I can replace. I replace 20 and 60. You just see that how it's happening. Any children smaller than 60? Yes, it is 60. So I'm just swapping 20 and 60, right? We have to swap with the only smallest. Okay. Now, second index also done. We can move to the first index or the first node, that is 40. And I have to check any of the children is smallest. Any of the children is smallest. Both the children are smallest, but the smallest is among those two. 10 is the smallest. So what I have to do? I have to replace 40 and 10. And again, it's not completed, right? And again, after swapping, I have to check whether it is properly fine or not. I just swapped 40 and 10. So 40 will come here. That time again, if I check, it will violate because 40 will come here, 30 will come here. Again, it will violate. So again, I have to swap these two. That we will see in the animation. Are there any smaller child is than 10? 40? Yes, 10. So I have to swap 10 and 40. Good. Again, I have to check whether it is properly created or not. No, it is not properly created because than 30, 40 is bigger. So what we should do? Because looking at this heap, we find 40 is greater than its children node. So we have to correct these two elements by swapping 40 and 30 here, right? That's it. And again, we will check with the second node. No issues, no child smaller than itself. And again, we'll move to the first node. No issues, it's perfectly fine. So now, finally, we created main heap. We will check any nodes, any node, any parent node. If we consider it is smaller than its children node, correct? It is smaller than its children node. So finally, we created main heap. So we have seen 5 steps, right? What is the first step? We have to build heap. Yes, we have done. Next step is we have to create a min heap if it is ascending order. Yes, we created min heap. What is the next step? We have to delete the root node and we have to replace the last node with the root node. So I can delete the root node, right? So it will come to the first position in array. And what is the last element in this array? What is the last element? 40 is the last element. So I can replace that 40 here. Just see how it is happening. I have to delete the root node. And I can put that root node in the sorted element list. Because the smallest element, right? So I can put in the sorted element list. What step I can do? I have to replace that root node with the last element. Now replacement is done. Now what should we do? Again we have to construct min heap. What is the property? That is, each and every parent node should be smaller than its children node. So where to start, where to check whether it is properly min heap tree or not. So how to reconstruct min heap tree? Nothing but we have to start from n by 2th position. So how many nodes are here now? 1, 2, 3, 4, 5 nodes are here. So which position I can start? 5 by 2. That is, we are using floor method. So it will give the nearest integer value. 5 by 2 nothing but 2.5, nothing but 2. First index, second index. So it will start searching from 20. Whether any elements are smaller than root node? No, it is perfectly fine. And it will go to the next smallest index. That is, it will go to the first index. It will check whether any elements are smallest. Yes, of course, both are small than root, and among these two, it will check which is lower value. Then obviously 40 and 20 will be swapped. Right? We will see with the animation. So we know that totally n five nodes. Finding the floor. So 2, we should start from index 2 or the second node. We are checking is there any child node smaller than 20? No. Then we can move to the first index. Is there any child node of 40 smaller than it? Yes, 20. So we are swapping 20 and 40. What will happen? And again, after swapping also, we have to check whether we created proper min heap or not. We can check whether finally we created proper min heap. Yes, it is properly created. It is all the parent nodes are smaller than its own child nodes. So what is the next step? We can delete the root node. That is the next step, right? What is the root node? 20. After deleting that root node, we can put in our sorted element list. Also, last element I can replace with that root node place. Then, as usual, we have to create min heap. So, totally 4 numbers, 4 by 2, 2. So, we can start from second index, 1, 2. Then any value is smaller than 40? No. So, I can move to first index. First index I'm checking. Is there any smaller node is there? Yes, both 40 and 30 are smallest, but among these two, 30 is the smallest. I'm swapping 30 and 50. Right. Now first node is also done. Then we are checking whether we have created proper min heap or not. Looking at this heap, yes, all the parent node are smaller than its children node. Yes, finally done. Min heap is created. What is the next node? We can delete the root node. Yes, I deleted and I put in the sorted list. And last node can be replaced with that root node. What is the next step? Again, we have to create min heap. So what is the step? Totally 3 elements, 3 by 2, 1.5, floor is 1. So we have to start comparison from first index. First index is what? I'm sorry, first index. So we are checking is there any smallest value? S. We have 40. So I have to replace 40 and 60. Now we are checking whether it is proper min heap. Yes, it is proper. So what is the step? Next step, I can delete this parent node, right? Because by looking at this, everything is fine. 40 is smaller than both of its children. So we have created the proper min heap. So what will happen? We can delete the root node and I can put in the sorted list. And what is the next step? I can replace the last element. Then again I can construct the min heap tree. So only two elements are there, 2 by 2, 1. So I can start checking with the first index. First index, yes, it is perfectly fine. No need to swap anything, right? So what I can do, because no child is smaller than 50 here. So it is properly, we create a min heap. So what we can do, I can delete the value 50 because no node is smaller than 50. So it is proper min heap tree. So what is our next step? I can delete the root node and I can put in the sorted list. I'm just deleting root node, put in the sorted list. And last node I can replace with the root position. Since only one element is there, no need to checking anything, no more elements. So only one node. So we can stop here because no left or no right node. We can stop here and put the last element into the sorted list. Right. Now we got the proper required sorted elements in the ascending order. Quite interesting, right? And with example 2, in the example 2, we'll just try to order in the descending order. Same points, we have to build heap. So next is we have to construct max heap. In the ascending order, we construct a min heap. In the descending order, we are constructing max heap. Right, that is the only difference. And rest all the points are same. After that, we have to delete the root node. All the points are same. So we'll see. We'll consider the example. Same example with 6 elements. So definitely our heap will have 6 nodes. How we can represent those nodes in array? Since array indexes start from 0, as I told, we can represent or we can read element from first position. Programmatically, it will be easy for us. First step, we have to build heap. And what is the property? One by one I can read. Left to right I can fill. Once the level is filled, I can come to the next level and I am filling left to right. That's done, right? 40, 60, 10, 20, 50, 30. That's it. From this constructed heap, I have to construct the max heap tree. So where to start? From which element I can start for creating a max heap? So what is the property? All the parent node. What are the parent node? That value should be greater than its children node. So where to start? We can start comparison from n by 2th position. So totally we have 6 elements. So 6 by 2, how many elements? 6 elements we have, right? 6 nodes. And 6 by 2, obviously 3. So first index, second index, third index, same way. Third index. So what is the property you have to check? Whether any child node is greater than 10 or yes, of course, 30 is greater than 10. So I can swap these two, 30 and 10, I can swap. Right, that's it. It's done. So I can move to the next second index. Whether any node is greater than 60, I'm checking. Any child node is greater than 60, I'm checking. No. So it is done. I can move to the first node. I'm checking any child node is greater than 40. Yes, 60 is 40. So I can replace 40 and 60. So we are checking whether we created a proper max heap or not. So while checking, all the nodes are proper. But here we could see it is not proper after swapping, right? So it is swapped with the proper largest element. Then next move, if there is anything greater than 60, no. So by looking at all the elements, We are checking whether we created a proper max heap or not. Comparing with 60, is there anything is greater than 60? No. So we reached the proper max heap tree. So what is the next step? We have to delete the root node and we can place that root node into the sorted element list, right? Because we are doing a descending order. And as usual, we can start with the last node is replaced with the root node. Again, we can start with constructing max heap. So totally 5 elements are there. So floor of n by 2, 2, 1, 2. This position we have started checking. Any child nodes are greater than 50? No. And we are moving to the first index. Any child is greater than 10? Yes. Both the child are greater than 10, but among these, 50 is the greatest element. So I am swapping 10 and 50. After swapping, again I have to check whether it is properly max heap or not. I'm just checking. No, it is not proper. Correct. So 10 is smaller than its children? No. So we have to correct it. Both are greater. Among these two, 40 is the greater. I am replacing 10 and 40. Now again move back to the first position. Again we are checking whether it is proper or not. Yes, now it is proper. No child elements are greater than 50. So what is the next step we can do? Because we reached the proper max heap tree. All the parent node are greater than its respective child node. So we reach the proper max heap tree. Obviously, what is the next step? I can delete the root node and put in the sorted array. And last node I can replace with the root node. Then again, the max heap creation will be started. Totally 4 elements. So 4 by 2, 2, 1, 2. I can start from this second index. So in the second index, I'm just checking any child elements are greater than 40. No. So I'm moving to first index. Any child node greater than 10? Yes. Both are greater. Among that greatest is 40. Swapping 40 and 10. So after swapping also, we have to check in all the place whether it is properly created or not. So by looking at this, 10 is smaller than 20, right? So again what we have to do? Swap 10 and 20. And again move to first position, checking both. So none of the children is greater than its root node. So now it's perfectly fine. What is our next step? Since we created max heap, we can delete the root node and I can put in the sorted list and I can replace the last element to the root node. Totally 3. First index we can start. Any element is greater than 10. Both are greater. Among these two, 30 is greater. I'm swapping 30 and 10. After swapping, I'm just checking with all the child elements whether it is properly created or not. Yes, it is properly created. So we can conclude we created a proper max heap. So what is the next step? We can delete this root node and put into this sorted array. Sorted element list, I can put that and replace with the last element. Right, again what we have to do? Creating the max heap. So total number of elements is 2. 2 by 2, 1. So first index, I'm checking whether it is any element is greater or not. Yes, 20 is greater than 10. We can swap both 20 and 10. 20 and 10. So we are checking whether we created proper max heap or not. So by looking into our tree, no children node is greater than 20. So we got the max heap in this step. What is our next step? We can delete the root node and put into the sorted array list, replacing last node to the root node. And since we have only one element, no left or no right element, we can stop here and put into the sorted array. So finally we got the proper descending order by constructing max heap tree. So in this session we have seen how to do the sorting using heap sort. So we constructed min heap, max heap. Min heap is for arranging elements in ascending order. Max heap is for arranging elements in descending order. So the steps to be remembered is we have to build a heap. Then after that we have to build max heap or min heap based on our requirement. Next we have to delete the root node. Then the last node can be moved to the root node. So again we have to reconstruct the tree to max or min heap. So repeatedly we have to do the same procedure till we get the proper sorted elements. So each and every time while creating min heap or max heap, what is the rule? In min heap, parent node should be the minimum than its children node. In max heap, the root node, the parent node should be the largest value than its children node. And while comparing where to start the comparison, there is a rule. From heap tree, you have to start from the n by 2th position. So these are the key points to remember in heap sort. That's always. Thank you. We will see you in next session.